Hello friends, in this video we are going to study that what is the procedure for converting a block diagram into a signal flow graph and how we can convert a signal flow graph into a block diagram. First we will start with the procedure for converting the block diagram into a signal flow graph. Now the first step for this conversion is that represent all the summing points, takeoff points and the input and output of the block diagram by the nodes. In the second step, you have represented all the summing points and takeoff points, input, output and all the other variables presented in the system by a node. Now draw an arrow and write gain or transmittance because you are connecting these nodes with the branches, so each branch will have an arrow and on that arrow write the gain or the transmittance, or you can say the transfer function over that arrow, and this arrow will show the flow of signals through the system. Here you have to keep one thing in mind, that the direction of arrow or the flow of the signal should be from input to output. Now the third step is we have drawn the summing points and takeoff points. You have represented them in the form of a node. You have connected the node with the branches and you have marked the branches with their respective gains or transmittance. So now you have to represent all the feedback signals. So in step 3, So in step 3, you have to represent all the feedback systems present in the control system in the same way. And also you have to put the sign. Keep in mind that whether it is a negative feedback system or it is a positive feedback system. So put that positive or negative sign with their respective transmittance or the transfer function and represent it on that arrow, so that we will get to know that it is a feedback loop or it is a feedback system. Negative sign will show that it is a negative feedback system or whether it is a positive feedback system. And in this way, all the feedback systems, they will be represented in the signal flow graph. Now in step 4, so these were the steps which you have to keep in mind while converting a block diagram into a signal flow graph. But just keep a point in mind. You have to keep this point in your mind that whenever you are drawing a signal flow graph from the block diagram, then the takeoff point which is coming after the summing point, then it is represented by a single node. Whenever the takeoff point it comes after a summing point, you have to consider it as a single node. But if the summing point is coming after a takeoff point, it is represented by two different nodes. So these points you have to keep in mind whenever you are drawing a signal flow graph from a block diagram or you are converting a block diagram to a signal flow graph. So let us take an example of how we can convert a block diagram into a signal flow graph. So this is the block diagram and we have to convert this block diagram into signal flow graph. So first take the nodes that for each variable, this is the input, that is x, so it is our node x, and again we have a summing point. For this we will have a node x1, then we have block G2, then we have this takeoff point. So this takeoff point will be taken as the node x2 and this is the output node y. So there are 1, 2, 3, 4 nodes. This node is for input, so it is x. This is for the summing point, it is x1. This node is for the takeoff point, so it is x2, and this node is for the output, so it is y. Now draw the arrows in the direction of the flow of the signal. So we have drawn x, x1, this is the arrow. This is the direction of the arrow in the flow of the signal from input to the output. Now let's write the transmittance. Between the node x and x1 we have the block having the transmittance or transfer function as G1. So on this arrow we will write the transmittance. Then we have between x1 and x2 we have the block G2. So we will write the transmittance G2 here. And between x2 and x1 we also have a feedback loop. So let's draw this feedback loop. The direction of arrow is in this direction. So we will draw the arrow, and then we will write the transmittance of this block with the sign on this arrow, that is minus H1. So in this way we can convert a block diagram into a signal flow graph, and step by step following the steps we have discussed earlier. So this was the procedure for converting a block diagram into a signal flow graph. Now let's see the procedure for converting a signal flow graph into a block diagram. So for converting a signal flow graph into a block diagram, the first step is write the equation for each node in terms of the incoming signals. So for all the nodes present in the signal flow graph, we have to write the equations, and the equations should be in terms of the incoming signals, that is the signals coming towards the node. So this is our first step. Now step number 2. In step number 1, we have write the equations for each node in terms of the incoming signals. Now in step number 2, we have to convert all these equations which we have obtained in step 1 into the block diagram separately. That is, each equation will be converted into a block diagram, and we will get the block diagrams for each equation. And when we are converting the equations into the block diagram, keep one thing in mind, that you should use summing point for the summation of signals. That is, whenever in the equations we are getting the sum of two signals, then we have to use summing point for that while conversion, and one block should be used for each gain or transmittance. Whenever a gain or transmittance is encountered, use one block for each transmittance. So you will get, after step number 2, you will get the block diagram for each of the equations. Now step number 3. In step number 3, combine all the block diagrams which you have obtained in step number 2, and when you combine all the block diagrams, then you will get the complete block diagram for the system. So let's summarize these steps. In step 1, you have to write the equation for each of the nodes, and these equations should be in terms of the incoming signals towards the node. In step number 2, you have to convert all the equations which you have obtained in step 1 into the block diagram separately. And while conversion, use summing point for the summation of the signals, and use one block for each gain and transmittance in the signal flow graph. Now in step number 3, combine all the block diagrams which you have obtained in step 2, and after combining you will get the complete block diagram for the system. Now let's take an example so that you can clearly understand that how we can convert a signal flow graph into a block diagram. So this is the signal flow graph, and we have to convert this signal flow graph into the block diagram. So let's start with the first step. First step was to write the equation for each of the nodes. So there are 4 nodes, x, x1, x2 and y. So we will write the equation for all of these 4 nodes. So x is the input node. So we don't have to write because there is no incoming signal towards this node. So we will not write the equation for the x node. Now for x1, we have g1x and minus h1x2. We have to write the equation in terms of the incoming signals towards the node. So at x1 there are 2 incoming signals. One is g1x and second is minus h1x2. Now for the node x2, the incoming signal is only one, that is g2x1. For the node y, we have the incoming signal as x2. So we have got 3 equations in terms of the nodes x1, x2 and y. Now for each of these equations, we will draw the block diagram, and then we will combine these 3 block diagrams. Then we will get the complete block diagram of the system. So for the first equation, we have the block diagram as, this is the input x, so we will draw x here. Then this is multiplied with the transmittance g1. So for g1 we will have one block, and the transfer function or transmittance or gain is g1. Now there is a minus sign, so this x2 and h1, they will be forming a feedback loop, and they are adding up with this g1x signal. So we have to use a summing point here for the summation of signal. g1x is having positive sign, so we will put here positive, and this h1 is multiplied with x2, so we will have one block for this transmittance h1, and x2 is multiplied with it, and these 2 signals, they are being summed up, and this signal is having the minus sign, and the output of the summing point is equal to x1. So this is the block diagram for the first equation. Now for second equation, we will have x2 is equals to g2x1. So this is x1 multiplied with the transfer function, that is transmittance, should be written in the block, that is g2, and here we will have x2. This is x1. So this is the block diagram for the second equation. Now for the third equation, we will have the block diagram as y equals to x2. So this is the node y, this is node x2, and x2 should be given to y, and this is 1. Okay, so these are the 3 block diagrams. Now just combine these 3 block diagrams, so you will get the complete block diagram as first part is this. So we will redraw here. This was the output was x1, and this x1 is multiplied with g2, so we will get x2. So here we are having this as g2, and g2 is here. The output is x2. Okay, now this x2 has been given to this summing point and multiplied with the transfer function h1. This is minus plus, this is x, this is x1, x2, this is output y. So this is our complete block diagram for the system. We have just combined these 3 block diagrams which we have obtained, and then we are getting the complete block diagram for the system. So in this video, you have seen that how we can convert, or what is the procedure for converting the block diagram into signal flow graph, and how to convert a signal flow graph into a block diagram. I hope you have clearly understood the topic. Thank you.